topic of the discussion today is industrial decarbonisation, the role of the European emissions trading system and how that fits into the context of the Green Deal in Europe. And we focus specifically on cement and steel today. And why? Because under the European emissions trading system since 2013, the power sector has decreased its greenhouse gases by almost 30%. Now, that's driven, of course, by rapid phase out of coal and lignite in the power mix, but the picture changes significantly when we look at resource and energy intensive industries in Europe, such as steel and cement, but also chemicals and others. They're also covered by the EU ETS, but hardly decreased any of their carbon pollution over the past 8 years. So with this challenge in mind, we do look forward to discussing how the European Green Deal and the European carbon market can drive industrial decarbonisation. We'll explore the barriers and opportunities to industrial innovation in the steel and cement sector specifically, and then have a look at the EU policy framework and discuss together with the panel policy solutions to improve things going forward. So we're very happy to be joined by our speakers and thank you to provide insights and knowledge to the debate. And we'll move straight into two presentations from a sectoral perspective, and they will talk a bit more about the challenge of decarbonizing the steel and cement sector. This is specific real-life case studies, which we will use to draw some lessons from for the EU policy frameworks. And there's a bit of a disclaimer here. And I think it's important to note that both speakers are in no way whatsoever affiliated to any company producing steel or cement. So we do have a rare occasion today to listen to sectoral experts which are not paid by the industry. And since this is a voice we feel is too often underrepresented in the stakeholder debates informing the EU institutions, specifically when it's about reforming and strengthening the EU ETS. So while we set up the first presentation, I'll introduce the first speaker, which is Valentin Vogl. He's joining as a PhD researcher from the Lund University in Sweden. And Valentin is working on the decarbonization of the steel industry, and he is directly involved in the research project called Hybrid, which is funded by the Swedish Energy Agency. Valentin is looking specifically at the development for a fossil-free value chain for the steel sector, and he studies also how climate and industrial policies can have an impact on decarbonization of the sector. We can see your slides and we look forward to your input, Valentin. The floor is yours. Thank you.
Great. Thank you, Sam, and welcome everyone. Good afternoon. As Sam said, my name is Valentin Vogl. I am a PhD student at Lund University in Sweden, and I've spent the last 3 years studying climate transitions in the steel industry. A quite nerdy hobby I found it to be, but very interesting. So I'm gonna talk today about 3 things. Mainly, I'll give an introduction to what deep decarbonization of the EU steel industry means, or EU steel system, that includes consumption, as an introduction. And then I will discuss the role of the EU ETS and make an argument that we need to do more than carbon pricing to really reach zero emissions in the steel industry. Starting from this, I'll provide some context. So the steel industry in the EU accounts for about 4% of greenhouse gas emissions. Globally, it's more. It's about 7 to 9%. And these emissions come mostly from around 65 blast furnaces we have in Europe operating. Europe produces around 170 million tons of steel each year, whereof more than half is produced in the blast furnace production route. That also includes other processes in the blast furnace, but the blast furnace as the main emission source is quite dominant, or comes to the foreground if you take a climate perspective. And then contextually, in the steel industry globally, we see a huge production overcapacity today, over 400 million tons, which is 2 to 3 times what Europe's total production is. which basically means that any new capacity addition will face quite a difficult market outlook, and steel prices are generally low. We're also entering the steel scrap age, as Stefan Pauliuk has called it. So more and more scrap is becoming available that we can recycle, and thus less and less primary production will be needed in some parts of the world. So this depends, of course, on the global demand growth in steel. But for sure, in Europe, there's plenty of studies that show that we can increasingly rely on secondary production, so recycling in the future, and do less primary production. And this has its own implications in terms of plant closures or realignments, but I will not have time to go into that today. And then finally, European climate policy regarding the steel sector has been called in a carbon leakage treadmill. So the carbon leakage argument has been brought up, or is being brought up time and time again, for example, to secure free allocation. And I would argue that the policy mix I suggest today can be a way also in overcoming that carbon leakage debate, that single issue debate, when we take a more transition perspective. So if we look at deep decarbonization in the steel sector, with deep decarbonization, I mean zero emissions or close to zero emissions or even negative emissions. And this is, the Paris Agreement is very clear on this. We need to go to zero in all parts of the economy. And we need to do this quickly. So in order to do it for steel, there's basically two strategies. One deals with material efficiency. So this means reducing demand for steel where it's possible, using high strength steel, recycling better, collecting steel better, and separating out the components that cause impurities, reusing, remanufacturing, and so on. And this is essentially a collective action problem where we would all be better off if we did this. But then there are some that have a very strong interest in not, for example, reducing steel production. So we need to find a way how to deal with that. The second part, which accounts for the approximately other half of decarbonization potential, is the development of low emission steel production technologies, primary steel production technologies. And these are not yet commercial, so there's a lot of R&D and demonstration efforts that still need to be done. And there's very many projects throughout Europe that are now looking into this, where we see today two main directions. One is electrification of industry, and the other one deals with carbon capture, as I will show in the next slide. So technologically, it's crucial that we focus on zero emissions, because 2050 is not far away, and there's plenty of technological options that's still being discussed that cannot go to zero emissions. And if we spend large amounts of public money on innovation or even investment grants, we need to make sure that these projects that get awarded funding are able to reach the net zero goal. And I said currently we see focus mainly on electrification that includes hydrogen produced through electrolysis of water. And we also see a second line that goes more into carbon capture and utilization. And there it becomes a bit tricky, in my view, with these technological dead ends that cannot go to zero emissions, because it gets very difficult to govern. So if the steel industry produces off gases from fossil carbon that are captured from fossil carbon, then we need to make sure that this fossil carbon eventually at the end of life of the chemical is either recycled again or captured and stored. So this will mostly work in a fully circular economy, of which I would question the feasibility in the limited time we have. So it becomes very tricky how to judge CCU, because for the steel industry, obviously it reduces emissions, but in the total system, the emissions reductions, although they will be there, will not be, or it will not go towards zero likely. So we also need to find a way here how to, probably we need to study it a bit more and get to terms with it. So if we look at the investment cycles in the steel industry, typically a blast furnace is relined every 20 years, which leaves you a good window of opportunity where you could do the transition away from the blast furnace or install carbon capture at the steel production site in the most cost efficient way. This doesn't mean that you couldn't do it in other moments, but it becomes more costly. But basically what we see if we plot 20 years from now and then 20 years from that is that we basically have one chance to deploy a technology that is ready for zero emissions after 2030. So if we go back to CCU, up to 2030, it would probably be a good idea to deploy CCU technology because it can reduce emissions. After that, we really need to be sure that this can be zero emissions. And to me, technically, it becomes more and more obvious that the steel industry it's possible to go to zero or very close to zero. So that shouldn't be a barrier. So if this was quite a short or crude brush over different technologies, but if we switch now to policies, we see that the main policy instrument that governs the steel industry in Europe today is the European emission trading system. The industry receives free allocation to prevent carbon leakage, and this will go on in the fourth phase, although there are some signs that it gets stricter, and there are a lot of discussions. I'm sure most of the audience is aware of this about border carbon adjustments. So we studied the EU ETS and the necessity of different policies for steel to quite some extent, and we mostly take a sustainability transition perspective that involves the different innovation phases and involves both the creative innovation part and also the decline, the destructive part, so phasing out technologies. And what we see is a series of limitations that we cannot just solve with carbon pricing alone. And this is in relation to more theoretical academic literature that criticizes carbon pricing as well within the sustainability transitions literature. I'm gonna zoom into two parts here because I don't have time to cover all of them. But basically here what I have under number 2 is that the EU ETS is inherently conservative. It optimizes existing systems, but it discourages radical technology shift. So for example, if a blast furnace steelmaker today would want to switch to another process that is not based on a blast furnace, let's say hydrogen direct reduction, then it's not clear today how big the allocation level will be. Theoretically, it should be the same. It should correspond directly to the CO2 mitigated, or the CO2 emission savings. But as the EU ETS today has product-based benchmarks, and the blast furnace is corresponds to the hot metal benchmark, then if a technology switch happens, the steelmaker might not get allocation due to the hot metal benchmark because it's a product-based benchmark. So hydrogen direct reduction might not be subject to the hot metal benchmark, as we see today in the direct reduction mill in Hamburg. They receive allocation due to a fuel benchmark, a fuel backstop benchmark. So it's very unclear how this will work, and this in turn creates quite some uncertainty to commit to these new processes. That's one problem we see. Another is randomly picking from this list the institutional lock-in that's already in place, where we see the research fund for coal and steel. We see plenty of research going on in terms of coke making and generally on processes that might not have or are on the way out to some extent. I'm not arguing that the blast furnace will be gone by 2050, likely not, but instead of basically subsidizing a technology where we know that cannot go to zero emissions, or that has difficulty going to zero emissions, we should spend more resources on nurturing actually learning in those technologies that can. So I want to argue from that a policy mix for transition and taking a transition perspective will be more effective in decarbonizing the steel industry. So this policy mix should recognize that there are different phases of a transition that include research and development, that include the early commercialization phase and the diffusion of technology, but also the decline and phase out of old technology. And I'm not saying this is obvious which technologies have to go in the steel sector. but I'm sure with a bit more research there, we can be quite clear on which technologies have to go. The unmitigated blast furnace, for example. This policy mix, it should cover different domains and policy instruments. So right now, I'd say we're in the innovation phase mainly. So we should consider R&D funding, which already is happening. But for an early commercialization or the commercialization of the first few plants, likely subsidies will be necessary, and also market creation of green markets can play a role there. At the same time, once we know that technologies will become available, we need to start talking about phase outs. Emission standards can be a policy instrument that can be very useful here as well. And all along these different instruments, the issue of just transition, in my view, should play a main role. And this is not only about who gets compensated for the effects of the transition, but it's also who is included in envisioning how the steel industry in 2050 looks like. So who is included in roadmaps being published, for example, who is recognized as a stakeholder. And in all this, the EU ETS still can play a vital role, but it shouldn't be the only instrument, as theory often suggests. But the EU ETS, for example, can be very valuable in creating data for where the emissions occur, but also as a funding mechanism for some of these programs. So to summarize, I argue that we should move from carbon pricing as a single instrument to a transition policy mix. And to some extent, this is already recognized in the industrial strategy that the Commission published. We should focus on, the policy mix should focus on nurturing learning and loosen the lock-in that is quite strong, for example, around the blast furnace production route. And it should, in each of its elements, address social justice. Thanks.
Great, thank you very much, Valentin. I think carbon leakage treadmill also kind of describes what I feel sometimes, having worked on the ETS for the past decade. It's a good analogy, I think. I take away 2050 or whenever we need to achieve carbon neutrality. It's basically today for the steel sector, and it's really nice to see not only the technologies presented, but linking that clearly to a policy framework which needs to be in place to get that done. If I'm not mistaken, I don't see any burning questions yet. In case there is need for clarifications on the presentations, we're happy to have very shortly questions to the speakers. But we can address that after the next presentation as well, so you can indicate clearly to who you're asked the question. I'll move on to the next speaker, which is Dekeukelaere, and you can already start sharing your first slide. Anne is the owner and managing director of Cementis Consulting. Cementis is a Swiss-based consulting company specializing in the cement sector. But Anne has also an impressive career behind her, working in the cement industry for 12 years for an international leading cement company called Holcim. Today it's merged and it's called Lafarge Holcim, as many of you will know. And in addition to all that, Anne has just completed her thesis in the field of sustainability for the degree of Master of Liberal Arts in Extension Studies at Harvard University. That work is, I'd say, very fresh. I believe it's about 2 weeks old since it's been finished. And Anne evaluated the introduction of new low CO2 cement within the European emissions trading system. I believe personally this is very exciting research, and we look forward to your presentation, Anne. The floor is yours.
Thank you, Sam. Thank you for inviting. So yes, let's talk about cement. First of all, I would like to go quickly through what is cement and how it is produced, but quickly, just to put the background. So the limestone here is quarried, crushed into small pieces. Then the raw material is then mixed with some additives. It goes in the preheater and it enters a huge rotary kiln There the flame reaches 2000 degrees C. And here what's happening is that there is a chemical reaction, the carbonation. So the CaCO3 transforms into CaO and emitting CO2. That's why we are heavy polluters. Then the clinker here is grind, stored, and then ordinary Portland cement is produced. We can also produce other cement by adding cementitious material. To be clear, the CO2 emissions that are considered in EU ETS in the production of clinker, so the product before cement, 40% comes from the fuel combustion and 60% comes from the chemical reaction somehow. So we have to understand that. So 40% is only the fuel and 60% is really the process. Okay, so let's look at quickly at the 40%, which means the fuel combustion. What can we do there is coming with new technology. Europe is one of the oldest industry in cement, so they had to shift through new cement kilns. The best available technology are the dry, here on the left, dry preheater and precalciner. Here in Europe, we only have 47–48% out of that. And the others then are without precalciner. We even have some wet kilns, semi-wet kiln, still in Europe. This is the technology. We will look at new technology at the end, but just that's the current technology. What can we do also is replacing coal by waste. But here they did a tremendous job, I have to admit. In Europe, they really tried to introduce waste replacing coal. But we have to know that waste, like tires, RDF, has a certain content of CO2 in their calorific value, except biomass, which is recognized as zero CO2 emissions. Here in Europe, we can see that today reach biomass and alternative fuel reaching nearly 50%, which is incredible. So that's acting on the 40%. Let's look at the 60% part. So the 60%, as I said, is the chemical reaction. So what should we do to reduce this part? This 60% is to reduce the product, the clinker product. We have to know that the clinker on cement ratio, which means that the proportion of clinker within cement is leveling off since the last 5 years. You can see here, it's really stable. Many years before, we were using a lot of fly ash and slag from the steel industry even. But this waste is decreasing more and more, like the fly ash from the coal power industry. We will close the power industry, so this availability of cementitious material will decrease. So I looked in my study at what is being sold in Europe. So here you have the average European cement portfolio. The CEM1, which is the pure cement we'll see after, is 26%, and the CEM2 with additives is 55%. So both of them is nearly the whole market, 81%. We need to know also, very important, that currently the standards, the EN 197 in Europe, only allows to go to a clinker factor of 65. I know the industry is trying to reduce it to 50% in order to reduce the CO2 impact, but the standards are in process, and I think there are some issues with the EU on this. So just basics. This is a CEM1, pure cement with clinker 95%, which means the CO2 content in this cement is bigger. A CEM2 you can have 15% of supplementary cementitious material like fly ash, pozzolan, slag. And now the University of EPFL in Lausanne, Switzerland, just discovered a new cement that could reduce the clinker factor at 50% by using calcined clay. So it has been proven that this recipe can totally replace this recipe, the SEM1, which means that you reduce from 95 to 50% of clinker, which has a huge CO2 content inside. So I was looking at that and I said, okay, what happens if I replace my current cement portfolio in Europe by the 90% SEM1? So the SEM1, I said, okay, 90% I put this new cement, and in the SEM2, 55% I change also. What would happen? These are my hypotheses of the study. I will not go into detail, but I considered the cement consumption as flat. I didn't took all the exports, imports, or newcomers, or closure of the plant. I tried to look at really the effect of the EU ETS, so I made it stable. I used the average CO2 content per ton of clinker that I found. So all the data, I found it on internet. So there is no any data that I received from any cement producer, anything. Everything was on internet. So I applied it to the phase 4 formula and with a new benchmark. So I updated the phase 3 benchmark. Here what's happened. So when I change to this new low CO2 cement, I have a reduction of 20% of the CO2 during the whole phase 4. This orange is the calcination of clay, one of the components. Since calcination of clay is not in the product benchmark, I had to add with the fuel benchmark. But we have to know that 1 ton of calcined clay is 211 kilo of CO2 compared to clinker, which is 813, so 74% reduction. So I looked at it and I saw that my optimal LC3 will provoke a reduction of allowances because I was under this minus 15% level. So I looked, I said, but I will lose allowances. What should I do? So I additionally did another scenario, said, okay, a break-even scenario. I incorporated this new low CO2 cement just enough not to cross this minus 15% clinker production. So what happened? Here what happens, in fact. In the dark green, you have the CO2 emission. So the business as usual is the current status. My optimal LC3 is the scenario where I put a lot of low CO2 cement in my portfolio. And the break even is somehow when I cheated a bit, if I can say that. I calculated here the free allowances. When I introduce a low CO2 cement, my free allowance decrease from 851 to 701. The allowances to buy, here I had 150 million. Okay, I have a bit less, but I have a decrease in free allowances. Then when I compared with a break-even, the break-even versus the optimal, the break-even, in fact, it has an increase of free allowances. I reduce also the allowances to buy, but it increased in CO2. Look at that, 797 versus 867. So I pollute more and I receive more free allowances. So conclusion, trying to benefit from the system is economically profitable, but not really optimized in terms of CO2 emissions. So my conclusion was the EU ETS currently does not incentivize a really paradigm shift towards a low carbon cement. I looked at a hybrid formula where I had to add an additional benchmark of clinker factor. It could solve the issue, but it's again administrative. So I looked at, okay, what happened if there will be no free allowances? So I took the average ex-factory cement price, 77 euro. I looked at the average CO2 prices, 38 euro. That was pre-COVID. So I looked at those two different cement, the CEM1 and LC3. You see that if I would have a tax on CO2, the tax on the CEM1 would have an increase of 39%. Compared to the low CO2, it would be only have 23% increase of cost. I would have a cost of 107 versus 95 euro. Then you might say, okay, but that's huge. So I looked, okay, let's look what is the effect of such a tax, a CO2 tax on a house. So I looked at the residential housing cost, the cost of concrete, and the cost of the cement in concrete, and thus the cost of cement in a house. We looked at it and I arrived at 2%, which means 2% of a cost of a housing is cement. I look at an average cost in Berlin, 100 square meters. I looked at the cost of cement without CO2, which would be 5,242. And then I added the CO2 for each of the cement. So, which means that if I want to build my house with OPC, it will cost me 7,200. If I buy the LC3 to build my house, it will only cost me 447 euro. It's just to show you the impact, because the EU ETS is only concentrated on cement, which is only the bottom of the value chain. I think we have to go further, which means that it's nonsense if we act only on cement, then the concrete producer add more cement in its formula, then the construction companies said, okay, I have to produce concrete, I will put the same concrete inside and outside, I don't care, I don't want to make different formulas. And the architects should also optimize their structure design. I will really recommend you to read this report from ETH Zurich and EPFL, where they really show on the field that we are using too much cement in concrete, too much concrete in a building, and architects are not also optimizing things. So it's the whole value chain. By adding, I think, a CO2 on cement, it would impact the whole value chain. Because if I'm a concrete producer and I see my cement, the CEM1 is more expensive than the other one, which is more green, I would take the greener one. And then the construction companies might say, okay, maybe I can take this cement, which has lower CO2 for the inside of my building and another one for the outside. So if all the value chain could be impacted through that. This was the clinker. I know I don't have much time, but quickly, the new technology. The issue with cement is that we cannot put it on electricity. No. People have looked at high solar energy, doesn't work. So we also look at CCU, CCS, but we are not there yet. We are looking at carbon capture post-combustion or direct separation. I know there are a lot of study ongoing with Leilac in Belgium. According to Sembiro, they will not be ready or economic feasible before 2030. So there is a lot of issue with pipelines, storage, and financing. So that's why it's an industry where we struggle and we have to come with new technology, but sometimes I doubt if we will be ready for all those years. Hopefully I was on time. Thank you.
Thank you very much, Anna. No problem. There is obviously a lot of detail behind this and a lot of research, and look forward to see that becoming publicly available as well. Obviously, we will share all the presentations after the webinar. I just wanted to pause briefly to check in whether there are any questions and answers, mostly for clarification at this stage before we hand over to both respondents. My colleague Agnese is keeping an eye on that. I'm pretty bad at multitasking, so just checking. Agnese, are there any questions at this stage?
Yes, we do have 2 questions in the Q&A section. However, I'm not sure they're entirely clarification questions. So if you prefer, we can move on with the next presentation and then have a look at these at the end. They are addressed, one to Valentin and one to Anne.
Well, I suggest Valentin and Anna have a look at those already, and let's then park them in the interest of time, move on, and then open up for the discussion with all 4 speakers involved. I'm sure that will be the most efficient way going forward. So I'll hand over immediately then to Beatriz Yordi. Thank you for joining us from the European Commission. Beatriz is a director for EU and international carbon markets at DG Climate Action. And Beatriz, while we set up the slides, and I think they're visible already, I mean, you are, and I say that very respectfully, in charge of the brain power within the European Commission, anticipating a major legislative review round of the European emissions trading system. It's coming up next year as foreseen under the European Green Deal and in line with the goal of achieving climate neutrality in Europe. And obviously we'll see only first indications of what that might look like in practice after the summer of this year, when the European Commission presents a plan to increase the 2030 climate and energy targets. So it's very early days, but we are nonetheless very interested to hear your views on the previous presentation, give a bit of perspective where the US ETS currently stands and where it's heading, and what are the main takeaways as from the perspective as a policymaker. So the floor is yours, and you can just let us know when we need to change your slides. Thank you, Beatriz.
Thanks a lot, Sam, and hello, everybody. A pleasure to be with you, with also after such a good presentations, and I know that the public is knowledgeable on ETS, so sorry if my slides are too basic, but I promise to keep a live presentation. So just Sam, next slide, please. And the next one, because it's a little bit too obvious. And you need to click twice there. Sorry for the instruct. Another one. Voila. So just to a little bit put the picture. We have, as you know well, we have put a system in the ETS, and I will try in my presentation to distinguish is inherent to ETS, which is at the end internalization of externalities, and what is depending on the design that co-legislators, so Parliament and Council, decide. And this I will start a little bit answering to what Valentin presented. That if I may say before going to MSR, I absolutely agree that the ETS is a major instrument, but it's not the single instrument. No way. I come myself from the renewable energy policies. I work in eco-innovation in the European Commission. So it's not only my career, thanks God, but it's a whole holistic approach that I'm sure we need to improve, and the holistic approach, but we go hand in hand with energy efficiency, with internal market, with renewable energies, and with resource efficiency. Very important that you have mentioned also. So just brackets, and let me go to market stability reserve. There was an inflation, there was an excess of supply, as you know. We put in place the market stability reserve, taking out allowances out of the market, and we see the change. And we see that it started to work, this in combination to the next slide, that I have to say that I personally like a lot. So next slide, please. Voila. I like a lot because it looks like a little bit our work has an effect, which is this determinism it's sometimes very positive and reassuring. So we have the co-decision, and you see the vote in the council, you see the votes in the parliament, we have the market stability reserve communication, prices started to grow. And this is, you know, and I will tell you a little bit the COVID times. Two messages from this graph. First one is that the policy making works, which is good. So it works. We see the impact in the market. And the second is that the ETS has passed the resilience or the strengths, the terrible test of COVID. So market was have a first reaction, and prices went down to 14 euros. Now up again this morning, 22.5. So we have passed the stress test, or we have passed. I mean, it's I can confirm that the ETS market is resilient to the shock. Big thanks also to the industry and power sector and aviation. We have a pandemic, and we still have, unfortunately, but the months of March and April are key for the ETS. April is the surrender month, so just to remind you, and this was a very good exercise of commitment from industry and power sector and aviation. Another message I'd like to say, and it's not on my slides, but Carbon Watch knows very well, we have last year, so pre-pandemic times, historic of emissions. We are around 9%, nearly 9% in the ETS markets, and 15% in reduction in the power sector. So we are seeing in the electricity prices, of course, together with the renewable policy. Let's be clear, has been a good tandem there of putting a price ETS. Also, coal prices went up, gas prices went down, and renewables were very aggressive in the positive way, impact. So 15% in the power sector, rather impressive. And for the first time, we have a 2% reduction in industry, which is good. Industry has been very shy in the reduction of emissions, and last year I'm talking about 1.5% of GDP growth in the economy, which is good, and 2% reductions for industry. Aviation, it was pre-crisis, and it was an increase of 1%, nearly 1%, which is small compared to the previous years that we were in 6 and 8. So 3 messages, 2 that you can see in the graph. One that I'm telling you is that the reinforcement of ETS worked. So it's not only a funding mechanism, that's just let me clarify, it's an internalization in the economy that can give results. And the second one is we resist the stress test of COVID. And the third one is excellent historical results in 2019 emission. Next slides. Next slide. I think you all need very well, and I share with you the slides. Free allocation. I like a lot Anne's recipe on clinker, new clinker, and I'm fully convinced that we need to do more in the part of standards, and clearly, as Valentin presented, more in the resource efficiency. For me, it's a must. Let's be very clear. I mean, carbon power market doesn't have, the power sector doesn't have reallocation, and we see a much faster reduction of emissions. The industry has free allocation for reasons that we know, international competitiveness, carbon leakage. So the system has, of course, some if you want, it's in accompanying the emissions, and it is what it is. And but if we will have a phasing out to 2030, and as some said, we will have a revision of the ETS in next year. So we will look at carbon leakage and free allocation. You know very well also that the Green Deal has put on the table the study of a carbon border adjustment, and to see if it's free allocation can be substituted for a carbon border adjustment. And we are studying this. We have started the debate and the exploring of this line. But we have a free allocation with some positive and negative aspects. And I understand the criticism of allocation, but we need to understand this free allocation also in a context of international competition. Next slide, please. So this is the shares. We can see is still big protagonist of the free allocation of phase 3. Clear big protagonist on the trade intensity and emission intensity. You see the paper or refineries and organic lower. And just to remind that the power sector does not have free allocation, and aviation. So just to say that we have, when we talk about ETS, there's something intrinsic to the ETS, which is the cap and trade. There's something intrinsic to the ETS, which is internalize and externality. And then the free allocation, how we design it, it's a problem of design, not an intrinsic problem of ETS, just to be very clear. Next slide, please. Reduction of free allocation. We know there was oversupply, mix of some rigidities, mix of economic crisis, for very different variables, also with the production level changes that has an influence in the system. And next slide, please. This is the cement sector that we see really an evolution on what is the effect in the free allocation. So next slide, please. Benchmark, as you know, they are based in the 10% best. You know very well that in phase 3, we have decided not to touch the existing benchmark. I really welcome this debate. Of course, I would like to hear also what the sectors think, what the parliament thinks, what the member states think. It's not I'm telling that it's a Pandora box, the benchmark, but we need to go piano there. Because I take good notes of your point of how a benchmark can also be a stopping innovation or a radical innovation, but just also a reminder that Horizon Europe, we are talking about 100 billions on the table. And I think that also Horizon Europe needs to be more innovative, more holistic, and more open, because many times innovation comes from the sectors, but other times come from outside the sectors. And also to remind that ETS provides fund to the innovation fund, that you know very well, but this percentage of how much goes to innovation fund is a decision. It's nothing inherent to the ETS. We have a van, and unfortunately, you said some brain power. I would love to have that power and the brain to just be able to turn the van as we would like around the table today. But it's difficult situations, and of course, I don't tell you that the situation that's the economic crisis that we are suffering now. But just to tell you that we have other instruments, some of them coming from the ETS, which is the Innovation Fund, and the other is the 100 billion Horizon Europe. And I'd like to say also one point. And pandemia is a tragedy. Pandemia is tough for the economy, but we are talking about an injection of money in the economy that is impressive. As you know, the recovery plan our president announced is 750 billions. And I think what is very important is that we align this recovery to a green recovery. And I can tell you that from the Commission side, recovery will be much greener than the last recovery. So this is something that we will need to use the opportunities, and I'm making a plea to all of us to not lock in investment that we will find negative in 20 years' time. So we have never, we need to use the cash injection opportunity and the whole recovery package to make greener the society. Next slide, and about to finish. So we assess the 54, we are in the benchmark exercise, NIMS correction, decision on cross-sectoral correction factor. What I can tell you is the preparation of phase 4, despite we have little time because the co-decision took longer than we wished. We are on time with all our lines, and we are ready for phase 4. Next slide. I will pass these two slides, Sam, if you allow me. Next one. It's just the innovation fund is there, is my main message. Please apply with all its beauties and difficulties of public money. But I think it is important that we have a holistic approach and that we use this change the image of a conservative ETS to a more forward-looking. So this is one of the instruments that could help us. So big invitation there. And my last slide, for allowing time for the debate, is the European Green Deal. So you know well that we have a change of dimension, a game change of league. Put it as in the words you like, but I can promise that from the internal perspective, not the external, what I see in the Commission after 20 years working in renewables and eco-innovation is clear. Green Deal is at the heart of European policy. It's not blah, blah. It's really a fact. And we will need to put, after summer, we will put a little bit the lines where we go. And in June 2021, we will say the relevant legislative measures that we will need to review or to upgrade or new ideas for getting towards the 50-55%. And that's everything from my side.
That's great. Thank you so much, Beatriz, for this. The date, June 2021, was in bold there, and I think a reminder for everybody here as a timeline to be involved. And we look forward to that. I believe you touched upon a very important point, and also we haven't discussed it much yet, the role of the funding for innovation and kind of looking where does the money go, also under the ETS. One of the pie charts at the beginning showed that the monetary value of the free allowances currently still stands at around 160 billion euros between 2021 and 2030. But at the same time, the ETS is also actually actively raising funds for industrial decarbonisation. And we have an innovation fund, which is operational, becoming operational by the end of this year. I'll move on to the next and final speaker. We are outside of the presentations right now. I don't think you have one. Ioana Popescu is Senior Program Manager at ECOS, the European Environmental Citizens Organization for Standardization. And in case you're wondering what it is, ECOS is the only environmental NGO worldwide specialized in standardization. The organization works specifically on defending environmental interests in the development of standards, not only at European, but also at international level, and also focuses on the development of technical environmental product policies. Ioana is part of the circular economy team, and we're very glad to have hear your take on industrial decarbonization, not only from an upstream ETS and carbon pricing perspective, but also the role of downstream material and product policies, as they were raised earlier as well. So thanks for joining, Ioana, and the floor is yours.
Thanks for having me, and thanks for the presentations that were given before. Yeah, at the risk of repeating things that have been said, but so we worked specifically on standards and technical policy, and we have been quite involved in the standardization, for example, of cement types, and might be happy to hear that we've been trying to introduce M2CM as a class into European standard EN 1971, but unfortunately it has proven to be a little bit more burdensome than anticipated due to the very legal framework around construction products in Europe. So that is also a separate discussion that we could have bilaterally. But our involvement has really revolved around trying to ensure that there is space for innovation, space for radical product improvements at the cement level, but also at when it comes to steel, and this across various European policies, standards, requirements, benchmarks, and whatever you might want to refer to when it comes to criteria. So we are really an organization working on standards in all shapes and forms, and therefore we also have quite strong views, and that we probably also align with with regards to the previous presentations from Valentin and on how radical product innovations should be made more accessible and actually be incentivized. And so for us, it's really a case of the ETS being a system that in itself does not actually implement the polluter principle pays in a very holistic way, because virtually every player indirectly is subsidized with a certain level of free allowances. And so from an NGO perspective, the polluter pays principle is much more, because from our perspective, the very fact of producing something with an associated level of emissions, environmental impact, etc., should lead automatically to having to pay for that pollution. And so in that sense, the ETS is maybe not holistic and complete enough to actually drive the polluter pays principle. With regards to also, for example, the benchmarking process that is maybe relatively technology neutral as part of the ETS, it doesn't really seem to drive, and this has been a bit mentioned before as well, it doesn't really seem to actually drive improvements in industrial production processes. And so for us, maybe a more impactful approach is to associate incentives, but also penalization. So having a carrot and stick approach. And so, for example, if a product benchmark is made to be extremely ambitious, it could create an incentive for improvement, but to drive this ambition continuously, you also need to ensure that whatever products or processes rank at the bottom in terms of emissions or environmental impact, so in other terms, what you would call the worst performers, that these are also gradually phased out, because otherwise you just observe a very, very large possibility or range of performance levels or emission levels, etc. But you never actually observe a concrete change in what is actually being made available on the market as a production process, or at the end in the form of a product to the consumer. So we really believe that to actually drive sustainable and continuous change, there is a need to combine both the carrot approach, so the incentivized approach, the funding approach, the let's say the softer tools, but also hard tools that gradually exclude worse performance. And so for us, even though the ETS might be able to cover with certain slight amendments, hybrid benchmarks were suggested and other aspects like this, but although the ETS might be able to cover a certain part, it certainly can't do all of it. And so this is why, in support of the European Green Deal and also the new Circular Economy Action Plan, we think that there is a way to, or there is an opportunity to design a policy mix that might be able to address entire value chains related to energy intensive products such as cement and steel in a more holistic way, and also in addressing the full life cycle of these products. And so from our perspective, this should indeed impact the very decision of running a plant at a certain point to the products themselves and their fate at the end of life. And so for this to actually happen in reality, or let's say how to translate this with certain dedicated policy instruments, there is already some opportunity in existing instruments, such as, for example, the Industrial Emissions Directive and its best available techniques, which for those of you that are maybe not so familiar with it, but it basically sets the permitting requirements for new industrial installations. And so if, for example, new industrial installations were aligned with best available technique, then we could at least make sure that whatever new investment that is planned in Europe actually corresponds to really the best in class when it comes to production processes. Another complementary approach to the production process aspect of the Industrial Emissions Directive, which, by the way, should also then include CO2, because otherwise, for now, it is a still incomplete tool. So if it were to include also CO2, this could then also have an impact on what products and on the competitiveness of the products that are actually being developed as a result of these production processes. And these products I want to refer to as, or people might refer to them as product standards, but I prefer to say product requirements, because yeah, a standard is, sometimes it's EN 1971, and sometimes is a standard like we would understand in our day-to-day lives. So I prefer we stuck to the word product requirements. So if we were to establish product requirements for industrial products such as cement and steel that are in line with circular economy objectives, then we should expect that such products are making, for example, best use of locally available raw materials, and especially secondary raw materials. So this was mentioned before. It's a case of ensuring that we actually capture and reclaim steel. It's a case of maybe making best use for cement production, making best use of available slags for maybe other industrial processes, or ashes, or silica fume, or glass cullet. So there are quite a lot of, especially in the cement sector, there's quite a lot of opportunity to substitute clinker to a certain extent, as Anne already mentioned, but we could even drive it further than LC3. And this is something that we need to make possible in the short to medium term. It's actually, I believe, a UNEP report from 2015 actually considers that clinker substitution is, in the short to medium term, the best way and the most impactful way of actually driving decarbonization in the cement sector. So it's really something, this circularity element and this element of tapping into locally available resources, it cannot be stated enough as being one of the main trajectories, or the main and most powerful trajectories to embark on decarbonization in the short to medium term. And I'd say that when it comes to especially cement, but I think it's the case for steel as well, and this was also a bit mentioned by Anne, but it's really important that we don't, when we look at, for example, steel cement production, we don't look at it with glasses that are outdated. So that we are expected to not put on ordinary Portland cement clinker glasses to interpret current cements available on the market. So for example, you cannot expect that an alternative binder, such as a carbonation hardening cement, will behave the exact same way as a Portland cement would behave. That's unrealistic, and that is irrespective of the binder chemistry that is behind these types of cement. So it's important that it is acknowledged that new radical product innovations will create or will have a behavior that will not be the one that you might know from ordinary Portland cement, but it doesn't mean that they will not deliver the mechanical strength or the setting time or whatever that you might find important for the building of your concrete structure. So it's important that the very characteristics of new products and alternatives are being taken into account when it comes to their end use. And there is no need ever to over-specify cement use, for example, saying that you need the structural resistance of a bridge when it comes to creating or developing a bicycle lane. in your city. So there is a case of making a better match between the products and the product requirements, or product standards if you wish, and the end application that they are used for. And this is how we can also make sure that we tap into more circularity potential, and that we tap into locally available resources, so that overall material input is minimized. And then an additional, maybe not so common, or maybe not so well known in this space, instrument, but that might still provide some value in complementing such approaches, might be the introduction of extended producer responsibility for energy intensive products such as steel, cement, and chemicals. So extended producer responsibility is probably very well known in the waste sector, because it was mostly implemented to cover for the costs of end-of-life treatment, disposal, landfilling, whatever, of certain products. So EPR was very often implemented to cover for these costs and to make producers accountable for the waste that they have produced. But more and more, EPR is being used as an instrument to cover the overall life cycle costs of certain products, and this could be a form. This could maybe take a form of CO2 taxation or environmental impact taxation on producers. So it could put a financial burden on them for designing products that are not in line with best available technique, that are not performant when it comes to a CO2 emissions standards that we would like to see. So EPR is a quite impactful and also quite popular tool in responsibilizing producers with regards to what processes and what products they are going for. And then I'd say that for at least to try to introduce even a more let's say holistic approach, and taking even more of a step back, a core principle of circularity and of all of the many R's that we refer to in the waste hierarchy, but not only, when it comes to really implementing circular economy and staying within planetary boundaries, there are steps such as prevention, and in prevention I count refusing, reducing, and not producing. So when it comes to this, I would maybe refer to it as something like a sufficiency principle or something like that. But there is a way to also take a step back and question the very fact of producing more and more material to be traded, but maybe there is no need for that material. So there is a case of trying to identify better and to manage industrial products better as assets, seeing how their use is maximized in time, and how maybe they could additional material production could be avoided by, for example, better managing existing building stock in Europe or in a specific country, by extending lifetimes of products, and especially when it comes to buildings, ensuring and construction, ensuring that the value and that the material value is capitalized upon over a much longer, let's say, time frame than we usually envisage with regards to commodities such as cement and steel. So I would say that these would be the main points from an NGO perspective towards decarbonization. But of course, I'm happy to discuss this further and answer any questions if needed.
Perfect. Thank you so much, Ioana, for this great overview of the carrots and the sticks you envisage for industrial decarbonization, also for broadening the policy making perspective a bit beyond the ETS. I believe there is already broad agreement on the panel that the ETS alone will not be able to do everything we'd like to see happening in those sectors. And the point you made on kind of doing more with less material reminds me of what happened in the power sector when we started to realize actually the best electricity and the best energy is the energy we don't need. So in the power sector, the principle of energy efficiency first is broadly recognized, yet in the materials and industrial sector, we're not doing that yet. I'd probably also, from a climate and environment perspective, the best steel and the best cement in Europe are the materials we don't need to produce in the first place. So let's dig into that a bit more deeply together with our participants. Again, my colleague Agnese has been keeping the overview of the questions and answers which came in. You can still ask them if you would like to, and I'll hand over to Agnese to direct the questions to our panelists.
Yeah, thank you, Sam, and thank you to all our speakers for the excellent presentations. We have a few questions that came in. I will start with Valentin. It's a fairly long question, so I'll try to read it to you, and otherwise we'll break it down in multiple ones. How would the technology mix look like for steel sector in a deep decarbonization scenario in developing and developed world in the coming years? Is hydrogen-based direct reduction the main silver bullet to decarbonize the sector? And then what's your take on the role of potential of CCS retrofit in the existing blast furnace technology, CCS implementation in new plants, bioenergy, novel technologies like electrowinning and decarbonizing the steel sector? So a variety of options that are put forward here. So feel free to start from wherever you want.
Yeah, I mean, I guess this is mainly about the technology mix, and maybe we can distinguish between developing and developed world, if you want to call it like that. But I mean, this is all about technology, and as I said in my presentation, I think one of the first lever. So if you look at the short term, we should go for material efficiency instead, because these technologies will not be available maybe in the next 10 years. So like Sam said, maybe it's best to produce less. But then, of course, this is not an easy thing to do, and it requires very many different policies, and also I think it's very difficult or different in Europe as compared to, for example, India, that is looking to expand its steel industry. So then I would say that the best technology for primary steel production depends a bit on the context. So if you have a country like Sweden with abundant renewable electricity, it makes a lot of sense to go for hydrogen from electrolysis. Whereas if you have a country that doesn't have access to renewable electricity, this doesn't make so much sense. So it's very, very contextual. And yeah, what is best from a climate point of view or environment point of view might not be what fits locally best. So essentially, I think it's a political decision as well. Yeah, I'm not sure which, for example, if you go to India, they use a lot of coal, they have a lot of coal, they would like to use their coal. So coal-based direct reduction with CCS could be an option there. I'm not advocating this at all, but it depends a bit what is already used there. If direct reduction is maybe already a thing in that country, then the barrier is potentially lower to go on with hydrogen direct reduction. Some countries also don't really accept CCS, so in those countries, hydrogen might be a better solution.
Well, indeed. As far as we can see in Europe, we have, as mentioned by Beatriz, the Innovation Fund that will start funding projects as of this year. And among the technology options, we see different ones, but we of course would like to see zero carbon options being prioritized. And as far as Europe is concerned, for steel, the direct reduction hydrogen base seems the more likely. Our next question would be for Anne. What is your take in the potential of geopolymer cement in replacing the ordinary Portland cement to decarbonize the cement sector?
So, in fact, geopolymer cement adds up to a lot of different, very specified cement that we can add up. But geopolymer cement, some of it uses steel slag, so from the steel factory. But as we know, the slag from the steel factory, from the blast furnace slag, we can use it. There is a lot of difference in quality. It's not available everywhere in the world. We also have to look worldwide to reduce the CO2 of cement. And we know that when the steel factory will go through electric arc, the waste or the byproduct from it, the slag, we won't be able to use it. So we have to know that the slag from the blast furnace, we can use it, but not from the electric arc. So we have to know that the slag volume which is available for the cement industry will decrease over the years. The same as fly ash. We use a lot of fly ash in cement. It will be going down very quickly, especially in Europe, because of closure of the coal power plants. So to say there is a lot of little cement types like geopolymer cement, there is a lot of others, but we have to add up to the LC3, like to lower this clinker factor. It won't be the LC3 at the beginning, they said, okay, we want to look at worldwide. They looked at what's available on Earth worldwide, except limestone. And the second level after limestone was clay. So that was, the Swiss government put a lot of money into this research at university to look at what is available worldwide in order to use and to reduce this clinker factor. We also may not forget that slag and fly ash in the beginning were waste product. That means that in the beginning were really like, take my waste. Now we have to understand that those are not waste anymore. Those are byproduct with a price. And currently I know that some slag has the same price as clinker. So I can imagine that the cement industry wants to go away from those products that are becoming more and more expensive, and the volumes are going down. And they want to go more to another source that they can master somehow. And yeah, it's an addition of small cement that are accepted, and we have to pull them out in order to reach this low clinker cement.
Thank you. I hope, I'm sure the question was answered in full. We have a follow-up question, which is a curiosity from a colleague who's wondering whether this LC3 you're talking about from Lausanne is already a patented technology, or only available to a specific company, or will be available for the whole market.
It was patented a couple of years ago, but the cement industry are challenging it. It's only patented in very specific country, maybe 8 countries, but I know it has been challenged, so it's in process. But otherwise, all the study and a lot of, in developing countries, look like whole Africa, there is no patent on it. So that means that we could implement that in Africa, where the normal cement they use is really the OPC, the same one. And that we have to stop now.
Fantastic, thank you. This is very interesting research as well. If I may, I see a couple of questions for Beatriz. They're sort of procedural policy related questions for our commission's representative. But we can quickly address them perhaps. We have, when did the European Commission plan to start the auctioning for the Innovation Fund? So auctioning allowances towards the Innovation Fund. and also when the final benchmarks for phase 4 will be published.
Thanks for the question. Before I go to procedures, and I will not switch on my camera, not to keep a good sound. Just before going to the questions you asked me, I would like to say something on the stick, and to Ioana. Great to have critical thinking. It's great to shake the policymakers. I think is basic. The actual prices of 25 euros is a stick of the size of 200 billion euro. So I think pas mal, as French said. It could be stronger, yes, or could be lower. But we are talking, let's do not forget, a stick size of 200 billion euro at a price of 25 euros. And then just, I think that the numbers from last year are rather impressive. So when we say that ETS is not working, we can say it can work better, true. But it will be rather unfair to say that 8.7% reduction of emissions in half of the economy means that it's not working. So for me, this is, I think I'm talking just purely factual. The 2% in the industry reduction, 15% in the power sector. In my country, that I come from, Spain, last year, switch coal was 66%. In Germany, the switch coal was 1/3. These are impressive numbers. And what we were designing that the ETS is going to hit the power sector, here we are, guys. So it's really kicking and doing the switch of energy. So this is our reality. And the not alone ETS, I think is something that I clap, that I take very serious from Valentin. And unfortunately, it's not only me, it's the President of the European Commission. So the Green Deal is all about a holistic approach to decarbonisation, including resource efficiency, biodiversity, taxonomy, financial access, infrastructures. So it's very important, and we will need from you targeted messages. So more targeted, because I think the idea of that ETS is not alone is there already. We are all convinced. So please, to the Commission, tell us more innovative ideas, like, for example, the new standard, why not, the recipe from Anne, if I can call it Anne, you allow me, or if also to convince Parliament and Council and stakeholders, because we will need your help in the timing. And after that, the procedure, I mean, I can put it back to Sam, but of course we are working on the monetization of the auctioning of Innovation Fund. I don't have the exact dates on my head, but we have done a good planning to obtain money from the Innovation Fund. The benchmark, we will be ready in autumn. So we will be ready for phase 4 on time and for January 2021.
Thank you very much, Beatriz, for this. I believe we don't have further questions, and that's actually quite good, because we've also come close to the end of this webinar. So I wanted to thank everybody for joining, and including our panelists for sharing their expertise and their insights. It is time to wrap up. Perhaps one suggestion, which I still saw in the chat box there from a colleague from CAN Europe, and I think it builds on the point, Beatriz, which you just shared, was an issue she wanted to raise on the need for strong support coming from DG Klima as well on the sustainability strategies. So looking at the strategy on sustainable built environment, on steel, and a chemical strategy. So I think that's also where we need to look at to make kind of this more holistic policy making on materials happening. And I hope that's a more concrete suggestion as you just requested. So to conclude, it's clear to me. I mean, we won't solve cement and steel sector decarbonization today. That would have been a tall order. But we did see real life examples of cleaner and breakthrough technologies which are in full deployment, development, and facing policy barriers today in order to mature to scale. So it's clear that the ETS is not only about safeguarding competitiveness of the industries of today, but the ETS also cannot afford to stand in the way of the clean technologies of tomorrow. And this conversation was focused on industrial decarbonization, the kind of hard to abate sectors, and we are very mindful of the great progress which has been made in the power sector over the past years. It made a world of differences. We have to acknowledge that, with the carbon price being around 20 or 25 euros per ton compared to 5 euros per ton where it has been for a long time. This is actually driving and actively driving coal and lignite out of the power mix. But for Carbon Market Watch, I can definitely say it does remain to be seen if the ETS will become also a help instead of a hindrance to drive industrial decarbonization, including in steel, cement, and chemicals. Because the resource and intensive industries of the future do need those decisions today. So concluding with that, I want to thank everybody again very much for joining us all today. My sincere gratitude to the 4 speakers as well for your input, the very rich discussion we've had. We look forward to seeing all of you virtually and maybe and hopefully even in person at a next occasion. Thank you very much and have a very nice day. Bye-bye.
Thank you, Sam.
Thank you, Sam. Bye-bye.
Thank you.
Thank you, Brian.